All right. This is Intro to Engineering Design. Um, and we will spend a lot of time on design projects. It's also just sort of an intro to engineering. So we'll, you know, um, talk a small amount about a bunch of different sort of engineering techniques and approaches. And um, it's, uh, it's sort of meant as a way to see if this is a field you'd like to keep pursuing. Um, what I'm going to do today is I'm going to go through the syllabus, talk about the class structure, show some examples of the kind of projects you'll be working on, just things that people have done in the past. And then after that, uh, we're going to go to Fusion 360. It's a CAD program that we're going to use on our first project. And we're going to get everyone signed up for student accounts. And that's all we're going to do today. Most people, are going to be done probably in an hour or something. Some people might have to stay a little longer if we're having trouble getting accounts open and stuff. But everyone will be done early today, I think. And then this is a hybrid class, which means some of the sort of lecture stuff is going to be given to you online. So, this afternoon, you'll want to look on D2L and there'll be an assignment with, I think there's 6 sort of shortish videos for you to watch and an assignment to do for the week. And then next Tuesday, we'll start really getting into CAD and learning some of that kind of stuff. Okay, so I first want to show you what D2L looks like and everything. I'm sure the majority of people here have done that before, but everything that we do in this class is going to go through D2L basically. And anytime I have information I want to share with you, it's going to be on D2L. So it's going to be important to be able to log in there. So for D2L, if you go to the main Normandale webpage, there's a drop-down menu over here, and you can go to current students. I think you could go to faculty too, but one of the things that pops up is D2L, and you need a star ID and a password to log into D2L. So if you don't have that yet, come talk to me, or you can just go to IT yourself. I'll just help you find IT and stuff if you need help. Sign in. And when you first get into D2L, it'll look like this with all of your classes listed. This is 1020 section 1. And when you open up the class, it's going to look like this. And the first thing you'll see is the announcements. There's only that one welcome announcement now, but as the semester goes on, I'm going to keep adding to those. You should get in the habit of checking that probably every day. Anytime I give a new assignment or make a correction on something or try to alert your attention to something, I'm going to put an announcement there. So that's the one that'll tell you like whether there's something new somewhere. And it might send you somewhere else on D2L, but this will always have something that tells you like you need this new thing. And like I said, this is a hybrid class, so there's always going to be additional instruction besides what we do in class right now. To start with, I want to go through the syllabus. That is under content. Once the class gets going, you'll be able to check your grades on stuff that's been graded here. You'll submit assignments here, but for now, we only care about content, which is where I'm putting all my documents and stuff. And there's not too much up here yet, but the thing that we want is the syllabus. And I'm going to just go through that to start with. Um, this is a 4-credit class. And so the first thing I want to make you aware of is um, the time expectation for this class. So you could Google this, how much time do I have to spend on a college class outside of lecture time or whatever, Google something like that. And no matter what university pops up, you'll be given the same answer to that. And the answer is, and there's always a little wiggle room in classes, some are a little less than this range, some are more than this range. But you'll always be told you should spend between 2 and 3 hours outside of class for every hour you spend in class. Okay, well, this is a hybrid class, so it's as if you're having 4 hours of instruction time a week, even though we're only meeting 2 hours a week. And so let's just base this off of the minimum of that 2 to 3 hours. I think if you spent that lower end amount every week in this semester, you do great in the class, have a great experience. So let's say 2 hours out of class for every hour in class. That's a total of 4 hours of class time. Half of that is class time, virtual. And then 8 hours in addition outside of that. So that's a total time commitment of 12 hours a week for this class. And like I said, I think if you consistently spend 12 hours a week on this class, you'll do great. You'll have a great experience. But I think it might be a good idea to look at your calendar and just make sure, look, do you have that amount of time available week after week? I know schedules are tricky. People are working a lot and stuff, but if you don't have that amount of time available, I don't think you're going to enjoy this experience very much, and your grade won't be something you're happy with and whatever. So make sure that you have this time and that you're ready to spend this amount of time on a class. And if anybody has any questions about this, or you have specific circumstances and you want to talk about that, I'd be happy to talk about it. But that's the first thing I want you to be aware of. My name is Gaio Lakin. Please just call me Gaio. I have a master's in biomedical engineering from the U, and then a PhD in engineering mechanics from the U. So my areas are more in the direction of kind of mechanical stuff than they are in the direction of electrical stuff. My office is right down the hallway over here, S1311. I do my office hours in the tutoring center, though. So if you're just coming to office hours, you won't need to know where my office is. But if you have trouble making it to my office hours and you'd like to talk outside of class, we can always schedule other times, You can contact me through email or with this phone, but I think the best way to contact me is through the instant messenger on D2L. So that is, if you're in D2L, on any page on D2L, that's the mail, like the letter icon up here. If you click on that, you can send instant messages, and I'll check those, every morning. And it's just it's a nice format, so I don't, with email, sometimes you'll get a million emails and then some will slip by you or whatever. This is easier for me to keep on top of. So if you can use this, I'd appreciate it. The class time is 10 to 12 on Tuesdays, and then there's additional instruction given through videos and stuff. My office hours, like I said, I'm going to do those in the tutoring center. And this is the room number for the tutoring center. It's just right up at the top of the stairs here. Tuesdays and Thursdays from 1 to 3, and then Friday from 1 to 2. And if you want to talk and those are hard to get to, just send me a message and we'll set up another time, either on Zoom or in person. Thinking way ahead, our final is going to be the Tuesday of finals week from 11 to 1. So we'll talk about that as that gets closer. The only prerequisite for this class is college algebra or an equivalent to that. We're actually not going to use a lot of math. I think really that prerequisite is largely just sort of a kind of a study skills type prerequisite. Make sure that you've taken the kind of classes that'll make you prepared for the kind of homework we're going to do and stuff like that. The topics to be covered. So like I said, this is an intro to engineering, and it's also a class in engineering design. And so we'll start out by talking about the different engineering disciplines, just give you sort of a basis. Like early on in people's engineering career, if you ask them what area of engineering they're thinking of going into, the vast majority of people say mechanical engineering. And, it's mostly because that's just the one that the most people have heard of. But there are a lot of interesting engineering disciplines, and many of them have special importance in the Twin Cities for whatever reason. So we're going to talk about that stuff to start off, just to give you sort of an overall basis. Then we'll start talking about computer-aided design. We'll be using the software package Fusion 360 that's made by Autodesk. And the nice thing, there's two nice things about Fusion 360. The first one is that as long as you're a student, it's free. So you can have a free account for your whole engineering career. The second thing that's nice about it is it has an online environment. It also has an installed environment, so you can install it on your laptop, and it runs a little bit more smoothly that way. But with the online environment, you can go to any computer anywhere and use it, as opposed to if a software package only has an installed environment, then you can only use it on computers that have it installed. And our first design project is going to be related to CAD and 3D printing. And then after that, we'll start talking about some circuits and electronics. And we'll learn a little bit of programming, and we'll use these in the robotics final project. The grading for this class is going to be pretty much 90, 80, 70, 60. I don't usually have to curve that. If the grades were really low compared to that, because say one of the tests was harder than I meant it to be or something, I would curve that down a little bit. I would never curve it up. So like, for example, if everyone in the class was over 90%, I wouldn't, everyone would get an A in the class. And that grading is broken down into these categories: 5% for these two, 20% for these two, these three, and then 30% for exams. And so now I'm just going to go through describing these different categories that your grade is going to be based on, just so you sort of know what to expect. The first one I call professionalism, consistency, and appropriateness. And this is worth 5% of your grade. And basically here, I'm trying to gently nudge you from the sort of informality of being a, high school student or whatever, towards by the time you graduate with an engineering degree, you kind of need to be ready to work in a professional environment. You need to sort of have in the back of your mind what your expectations of your coworkers are going to be and your employers. And so 5% of your grade is going to be based on this combination of things: attendance, being on time, turning in work on time, being prepared, being aware of what appropriate participation in class is, as opposed to, that's not one that comes up real often, actually, but every once in a while there's a student who, normally I love answering questions. If you have a question, probably there are other people in the class who have that same question and maybe just haven't sort of solidified what that question is yet. But sometimes I'll have a student who asks more questions than everyone else in the class combined, and it gets to the point where it's slowing down the whole flow of the class, So some of these are just kind of being socially aware of what what people expect behavior-wise. Same thing with lobbying for grades. I'm always happy to, if you think, I made a mistake in grading a question on your test or whatever, of course I want to get the grades right. But if it gets to the point where it's almost every question on almost every test, you're like, could I get one more point here or whatever? That also isn't really appropriate. Following assignment instructions. If I ask you to turn in an assignment in a PDF format and instead you turn it in as a collection of 16 Apple proprietary photos or whatever, that's just not paying attention to instructions. That's all part of being sort of detail oriented, presenting yourself appropriately as an engineer, Okay, so that's 5% of your grade. Most people in the class will get all of those points at the end of the semester. If I take off a point or two for that, I'll always give as detailed of notes to you as I can about why. It's something you can just work on in the future. 5% go to lecture quizzes. So most Tuesday class meetings are going to start with like a 10-minute quiz. And those will just be short answer questions about things that I've said in class, just to make sure that you're not only in class and taking notes on class, but you're periodically going back through your notes and trying to remember things that I've said. Okay, that's an important part of this. It doesn't do any good for me to say this stuff if no one's remembering it. And so trying to encourage that. Also, I do it at the start of class so that people get here on time. So if you miss those quizzes, no one quiz is worth a ton of points. Each quiz is somewhere in the ballpark of 1% of your grade. But I'm not going to do makeups for those unless we've talked about it beforehand, Then 20% of your grade is going to be weekly assignments. Those are basically your homework for the week, every week after class, maybe the afternoon after class. I'll have an assignment posted that tells you if there are videos to watch or things to read, and then it'll tell you what problems to submit. And those weekly assignments will always be submitted through D2L into the assignments folder. And I'll give you more details on that when I assign the first thing. And then finally, exams. I noticed this is a typo. There are 2 exams. The exams add up to 30%. So this really should say each exam is worth 15% of your grade. And the dates of the exams are here. So uh, the first one is Tuesday, October 13th. And we'll talk more about that as it gets closer. And this is kind of a tentative schedule for what we're going to do on all of the Tuesdays throughout the semester. You can see we're going to start out by talking about Fusion 360 and working on your first design project. Then we'll get into electronics and circuits. We'll get into some programming. And then we'll spend a lot of time working on these group robotics projects. This is a pretty fun class, actually, as long as you're not, getting behind. No class is fun if you're way behind, but you get to go through the project, especially with this robotics project, of kind of imagining something, thinking about what you want it to do, and going through all the steps of 3D printing parts for it, designing the electronic circuits that allow it to run, programming the microcontroller, and in the end, I'll show you some videos, but you have this thing that performs a task, and it's just for most people in this class, you've never done anything like that, and it's just a really cool process. The cheating policy, so cheating now in school is largely just using AI when you're not, when your professor doesn't want you to use AI. I will try to be clear as the semester goes on about when I don't want you to use AI. I think it's basically like any calculations that I'm showing you how to do in class, homework related to that. I don't want you to use AI. I want you to think through it, understand the process. But on these projects, you can feel free to use AI. I think it's a helpful. It's helpful with technical things like programming and electronics and stuff, and I do think it's reasonable to use it in this class for those. So if you ever have any questions, I mean, like I said, I'll try to be clear about when I'm fine with it and when I'm not fine with it. If you ever have any questions about it, let me know. Okay, and then everything else on the syllabus here is stuff that is required by the school, but there's some useful information here. I'm not going to read through it, but you can read through it, and I'd be happy to answer questions if you have any. But there's stuff about the school's policy on artificial intelligence, code of conduct, the OSD office, Title IX. So if you're interested, you can read through all that stuff. You might notice that I have a recording going. All of these Tuesday classes, I'm going to record. Like a lot of it, when I'm teaching you how to do calculations and stuff, it's going to be the equivalent of lecturing on the board, a lot of it. And, in a class where someone's lecturing on the board, you want to write down notes of everything that I'm writing on the board. Instead of being up at the board, I'm just going to be doing it as on a tablet on my computer. But the nice thing is then once I'm done lecturing, I'll be able to post PDFs of everything that I've written and videos of the lecture, like of me writing while you hear what I'm saying. And so if you can't make it to a class or you want to look again at what I said during a class, you'll have all that stuff available to you. Anybody have any questions about the class structure? Okay. Well, I want to show you, so we're going to have two design projects. The first one is an individual design project related to CAD and 3D printing. And so everyone's going to do their own. And I want to show you a few of the projects that I've had recently. So you get a sense of like what kind of thing you're going to do. I think the instructions say just something like, start out by sort of brainstorming some small plastic parts that would be useful in your everyday life, and you can try to think of something that might be useful to everybody, or you can try to do something that's like, I have this stupid drawer that won't stay shut, like I want to make something that, something that's very specific to your needs. Either of those are perfectly fine. The more something gets used, the more it appears that you've made something that's going to get used, the more I like it, kind of. So let me start by showing just a couple of these projects that people have done. And I just have videos. I happen to have videos of these three. I don't think these are the worst or the best or anything. They're just three that I have videos in this folder for. But this first one, it was a student who does a lot of crochet, and she's like, I just keep my stuff in a bag and it gets tangled and everything. I just want to make a organizer for my crochet things. And so most of the time on your project is just going to be spent thinking, and in the more detail you think about this and share your thought process with me, the better you'll do on this project. But like, how big do these holes have to be? Why is this size better than a little bit bigger, a little bit smaller? She has these straight up and down. Why is straight up and down better than at an angle this way or something? The more you can share a detailed, careful thought process with me about what you make, the better. So uh, she made this thing that fits most of her crochet hooks. It has a spot in the middle that fits some irregularly shaped ones. Would it be better if this hole was bigger and then she could hold the spools of yarn that she uses? Maybe. Uh, so those are the kind of things I want you to think about as we go through this process of, like, first you're going to brainstorm a thing, you're going to think about what you want, and then for a couple weeks you're just going to be spending your time thinking about and writing to me about, like, what can I do to make this more useful. um, it has to sit on a desk or something. Like, is this, would it be helpful if it took up less space on the desk, or would it be helpful if you could secure it to the wall instead of a desk? Those are the kind of thoughts that I want you to be having as you go through this. But this is a thing that was designed in CAD and then 3D printed in our lab, in our 3D printer lab. This one's a jewelry stand. Okay. There's places to hang rings and necklaces and whatever. There's some little things here. Why were these sizes chosen for these little bins? Would bigger be better? Smaller be better? Would it be better if these were at an angle so that things didn't slip off of them? That's the kind of thought process I'm going to want you to be going through as we work on this stuff. And then the last one I have here, Uh, this is like a headphone cable organizer. Um, it's sort of a cool kind of unique approach to it. Um, this folding shape. Um, okay, so it's made out of a bunch of different parts. Uh, it forms into that 1, 2, 3 hexagon uh, that you wrap your cable around, and then when you're done using it, it can fold up into a shape that takes up less space. You know, sort of a cool idea. Then you can fold it up small. You know, like maybe there would have been a way for it to fold into an even smaller shape if those things could nest inside each other or something. You know, maybe that would have made it more useful. So all of this is the kind of stuff that you're going to want to think about as you make this. Um, the the product you design is not really the key to doing well on this project. Uh, Having good, um, being clear to me, communicating the thought process that went into each one of these design decisions is really what's going to determine, you know, how well you do on this project. Okay. So that's the first project, and that's individual. Everybody's going to do their own, and we'll 3D print it at the end. You'll have this thing. Um, and then the second project is a group project in groups of 3 or 4, um, I guess 2 to 4. And that is the robot project. Oh. And so let me show you a few of these. These are just some recent ones. Um, well, first, I just started teaching this class again recently after a long time of not teaching it. So let me first show you some of the ones that were made the last time I taught it in. So this is, I think, 2009. Um, 2008. Uh, okay, so the first one, this is a card shuffler. So there's a deck of cards sitting over here in a hopper, and there is a sensor that's looking for whether it can basically see the sky or not, um, looking up here. And these wheels are shooting the cards one by one into this other hopper. And once they've shot all of the cards out, this um, this sensor sees light, and so it knows all the cards are gone, and then it tips it back in here and does it again. So it's shuffling cards is the idea. Um, and you know, there are ways that this could be improved. It's done with like Tinker Toys or whatever. Like it could be done with a more sort of polished appearance, more durable. Um, you know, better looking electrical interface or whatever. But still, I mean, this is a cool project. It does its thing well. So you can see that wheel shooting those cards in there. And now all the cards are done. The sensor recognizes it and drops it back in. Um, okay, this is just like pretty simple one. This drawbridge just is looking for whether a vehicle blocks like a light path between two light sensors. Um, and when it does, it lifts up the drawbridge so the car can go through. But very simple, but done well. The um, the mechanical motions are nice and smooth, and everything looks good and durable and consistent. Uh, I think this is just it just looks for a target and drives towards it. This is the one that I was sure was gonna like kill somebody during this. This is a they like found a refrigerator like in someone's garbage or something like, and they took it, cut a hole in it, uh, put this like launching system in it. So when you, I think when the person presses a button of like what kind of soda they want, this thing like loads that launcher and throws this soda can at them. Uh, it wasn't the best one, but it was like everyone's favorite. Everybody wanted to try to catch the soda cans. Blackjack dealer. Um, this one obviously could work in conjunction with the shuffler. Um, so you tell it how many players, and it just goes and okay. So those that's the kind of thing that you can think about. And then here are some recent ones. This one is, you could think of this as like equipment for a physics lab. This measured the coefficient of friction between two surfaces using force sensors. Um, so it started sliding, and it's measuring the force that friction applies to that back thing. Um, it keeps measuring it until those readings start to be consistent, and then it gives the coefficient of friction on the screen. This is a drink mixer. Um, this is, you know, a simple idea, but really well done, except they could have done, put a lot more work into the look of the front. But anyways, um, there's lemonade, iced tea, and then a mix of the two, Arnie Palmer. Um, you press which button you want, and it does a couple of things. First, these sensors here check to make sure that there's a cup in there, so it's not going to just pour liquid onto the floor. And then this reads out what you've ordered, so you know what it's making for you. So if you press it, there's no cup in there, nothing will happen. You can see the screen telling you what it's giving. And all of these things, they're simple, but they take programming and wiring and stuff. This is another sort of similar to that robot that drove around looking for the target. This is a line follower. So you put down a black line on the floor and it'll just drive along with it. People have done things like this a million times, but this was a nice execution. Like, notice that the chassis of the vehicle is 3D printed, and it just fits really well. And some of their electronics was done using a circuit printer instead of instead of just plugging wires into little connectors. And so the overall look is just really solid and clean, and it worked consistently and well. And then for some reason, this video doesn't even show it following those lines, but it does. And then the last one I have here is so they have a pump pumping water from one tank to another one, simulating like water flow in your house or whatever. And then they have a sensor that's checking to see whether there's any water leaking. And they simulate a water leak with a little valve they can turn on and off. And when this sensor measures moisture on the pipe, it shuts off the pumps. You can imagine that that could be a useful thing from preventing sort of catastrophic water damage in your house. So it's pumping, they turn that valve on, and the sensing moisture, that red light turns on, and the pump shuts off. So those are a few of, the kind of thing you can think of that we'll do for the robot projects. Anybody have any questions about either of the projects right now? Obviously, we'll talk about all this stuff a ton as we start getting into it. And we'll talk about how to use specific electronic devices that, yeah.
So you were mentioning in terms of like grading the Fusion 360 project,
yeah,
it's more on our ideas and the background thoughts that we had.
Yeah.
Is this project going to be a similar thing where it's more so graded on your
Yeah, that's right.
Than it is yours?
Yeah, it's really so I guess the part of this class that is about engineering design is really just trying to get you in the habit of being detailed and sort of conscious and sort of systematic about the process of refining your design, And so, yeah, that's true in both of those cases.
Thank you.
Yep. But it definitely is more fun. These projects are more fun if you have something that you like the thought of working. You know what I mean? Like if you have something that you're really looking forward to seeing work, it definitely, you'll enjoy it a lot more. But so that's why even sort of simple things can work okay for these projects, because there are always improvements you can make. And again, we'll talk more about that as we get going. Any other questions right now? Okay. Well, how many people here have laptops with you? Okay, great. That makes it easier. Hold up your hand if you need to borrow a computer. Okay. Let's go. Well, I'll just grab some laptops for you. What we're going to do now is get everybody registered for Fusion 360 so that we can start working on this next week. So here is what I want you to, the website I want you to go to. And by the way, think if you've ever had a class where you've used Autodesk before, or you've done this in the past, you don't have to register again. But I think for almost everybody, you'll need to do this for the first time. So I'm just going to write down what you need to do to register for the first time. So this is Fusion 360 registration. So first go to, I'm just going to write this all out, sort of a pain, but HTTPS, and then autodesk.com/education/edu hyphen software. /overview. Um,
Real quick.
yeah.
So if I do have an Autodesk account, should I make a new one for the student email?
Oh, you have one like for yourself that's not for a school, or is it for a different school?
Yes, sir. I have a personal Autodesk account.
Oh, and well, you probably could just use that, but maybe you should. Can in a second I'll come look and see if you have access to the stuff that we need.
Yeah, yes, sir.
Do you have it for work or something?
Yeah, I have
Oh.
work and personal use.
Oh, okay. Yeah, you can use that fine. So, do you use Fusion 360 already?
I don't use Fusion 360. I use AutoCAD.
Oh, okay. I think I'll have to think about that, but I think if you'd prefer to use AutoCAD for this class, you can do that too.
Oh, okay.
You know, so but Fusion 360 I'm sure is very similar, you know.
Yeah, or to Fusion 360,
Yeah.
I think it's akin to SolidWorks.
Yes, that's right. Okay. And if anybody's having trouble getting into this, maybe help the people at your table get in. Usually, if there's an issue, it's just because you typed in a letter wrong or something. There's a lot of places you can type something wrong. And then once you've done that, I think you're on a page where it's just going to ask you to verify your, so you're going to enter, so you need to enter your account information and be sure that you use a school, and actually, I think any university or college email will work, but don't use like a Gmail account or something when you fill that out. And at some point, I think you'll have to fill out the Normandale address. So that is this. Uh, 9700 France Avenue South. Bloomington. Five 55431, I think. And so just go through the steps of registration, and if you run into any snags, call me over and we'll figure out what to do. And I'll show you what it looks like once you get through all this. Um, so then you'll go to fusion.online.autodesk. And it'll give you the option to launch Fusion. And it'll count up this percent, and eventually you'll end up in the Fusion 360 environment that's where we're going to start on next Tuesday.
What was exactly what happened after we got the Fusion 360 like information filled out?
Have you already filled out your student information and stuff? So go to fusion.online.autodesk. And if everything worked the way I hope, you should see a launch Fusion button over on the lower left. And this is the environment we're trying to get to eventually.